All right, all you mathematics learners, here we go with some geometry today. We're talking about circles. In particular, the learning objective is that you should be able to find the area circumference of circles, and you should understand the relationship between central angles and intersected arcs by the end of this video. So we're going to start with a review of area and circumference, look at central angles and intercepted arcs. Before we talk about the area of the circle, I'm just going to give you a little reminder about some of the parts of a circle. We have the center of the circle that is equidistant from all of the points on the circle. We have the radius, which is a line segment connecting the center of the circle to a point on the circle. And we also have the diameter, which is a line segment going through the center of the circle and connecting to endpoints on the circle. And it's important to remember that the diameter is equal to 2 times the radius. And those are the important parts of the circle that we need for right now. The area of the circle is calculated as pi times the radius squared. And so in this situation, we have a radius of 3.5 centimeters. So we can say that the area of that circle is equal to pi times 3.5 squared. Since 3.5 squared is equal to 12.25, we can say this is 12.25 times pi square centimeters. So that is an exact answer. If we want to give an estimate, then we take that 12.25 and we multiply it by pi if you have a calculator with a pi button on it, or by 3.14 if not, then you get about 38.48 square centimeters. So after that little refresher on area of a circle, let's look at the circumference of a circle. The formula for circumference is usually 2 times pi times the radius, r, or we can also say pi times diameter because the diameter is equal to 2 times r. So in this case, the circumference of this circle is equal to, well, we're given the radius, so it's 2 times pi times the radius, which is 3.5, which is exactly 7 pi centimeters. And again, if we want to give an estimate here instead of the exact answer, we do 7 times pi and or 3.14. Our answer would be right about 22 centimeters. So that takes care of our review. Now we're going to move on to central angles. I'm going to give a little definition here. A central angle is an angle whose vertex is the center of the circle and whose endpoints are on the circle. So in the general situation down here, here is our central angle theta. We have the point C is the vertex of the angle, and the points A and B are on the circle, and they are the endpoints of the segments creating the angle theta. we can talk about the measure of an angle, of a central angle. So in our example over here, we have measure of angle RAT is equal to 81 degrees. And of course, we could similarly say measure of angle TAR is equal to 81 degrees, and those are both central angles. All right, now on to arcs and intersected arcs. An arc is part of the circumference of a circle. Now, since the circumference is the entire way around the circle, an arc is just part of that. And there's one arc. We can call that arc CR. And notice that if we are thinking about this side of the arc over here, would we call that arc CR as well? Well, that would be confusing, and we'll talk about that in just a little bit. An intercepted arc is a situation where we have a central angle here. There's our central angle. And the intercepted arc has the endpoints as the endpoints of those line segments. So to be a little bit more specific, the intercepted arc is an arc that is cut by line segments. So in order to get a little bit more specific, we have to talk about different kinds of arcs and semicircles. The minor arc is any arc that is less than 180 degrees. A major arc is any arc that is greater than 180 degrees. And a semicircle is any arc that is equal to 180 degrees. So in this case, we can talk about arc AC. That is certainly less than 180 degrees. So we can say measure of arc AC, and that's how we make that look. We put a little arc over the AC, is less than 180 degrees. To tell apart this arc AC from this arc that we might also want to call AC, that's a major arc. That's a major arc. It's greater than 180 degrees. And so we use 3 points to identify it. We could say that the measure of arc AEC, which is equal to the measure of arc ADC, and that is greater than 180 degrees. And for the last little bit of our explanation here, a semicircle is half of the circumference of a circle. So measure of arc CDE, whoops, make sure to put an arc there, not a line segment, is equal to the measure of arc EDC, which is equal to 180 degrees. And that's the general idea. Let's look at an example. Here we have this minor arc, CT. So the measure of arc CT is equal to the central angle that corresponds to it. So we have a central angle there of 150 degrees. So the measure of that arc is also 150 degrees. The major arc that is associated with that minor arc CT would be measure of arc CLT. Well, and that has to be 360 degrees minus the 150 degrees because 360 is the entire circle. Subtract the 150 and we get 210 degrees. If we extend the radius here of CA straight through to the other side and create another point here, point D, then measure of arc CTD. Whenever we're talking about a semicircle, we use 3 points, is equal to 180 degrees. All right, I hope that you feel comfortable with arcs and area and circumference. You can move on to the next video.